project, we are required to design an IC with minimum 12 transistors. For this project, we built a Boolean equation D equal to A bar plus BC bar, where is A is 4 transistor, B is 2 transistor, and C is 4 transistor. Because this Boolean didn't have a long bar, we have to put an inverter because the design tool has internal requirement or constraint that necessitate the inclusion of an inverter. This requirement could be related to circuit stability, power consumption, timing consideration, or other design constraints specific to the tool. So, this equation fulfills the requirement minimum transistor needed in this mini project.
After sketch the schematic based on our mini project equation, we are required to sketch a Euler path, stick diagram, and a layout plus DRC. In this part, we choose Moody's Euler path, which is A bar, B, C bar, stick diagram, and his layout plus DRC sketch, as he fulfills most of the mini project 4 requirements.
Good day to everyone. In this design methodologies, our group will actually done the mini project based on EDP. EDP is engineering design process. Now let's talk about schematic flow. Each team member complete a truth table, a Boolean equation, and a schematic circuit. Next, we construct a schematic Euler path for one of our team members. Create a schematic layout using a stick diagram in Red Hat software. Create a symbol and run the simulation to produce the waveform. After all of this, we calibrate for DRC defect and fix them one at a time, running LVS normally and completing the schematic layouts.
So, as you guys listened to Neva earlier, she had mentioned the EDP, or engineering design process. So EDP is actually a guideline, or sort of like a guideline for us to follow in order not to misconcept the requirement of the mini project. So EDP has 8 steps, which is ask, imagine, plan, create, and then test, and also improve. All I can say is we're actually more at plan, where Dr. Hafiz has produced us the PowerPoint throughout the mini project timeline, which is MP01 until MP08. So in order for us to decide which one is the best one for us to do in this mini project, at the MP02 we have SWOT and also SMART analysis that we can use in order to pick the best one. So here, as you guys can see, the point, or the highest point, goes to one Ani Sophia, as her schematic design or Boolean equation follow the requirement of the SWOT and SMART analysis, and also that easy for us to produce the output. And also in the MP02 we have the role responsibilities plan, where we divided our tasks of the one of the each member, like what we need to do in mental graphic later. And also at the MP04 we have the Euler path, stick diagram, and also the RC design that we need to sketch by our own hand or at the PowerPoint. So actually, before we continue at mental graphic, based on the role and responsibilities, we have to pick the best one of the Euler path, stick diagram, and also the RC as our guideline for us to move in the metal graphic. So here, as you can see, the best one that we pick is actually Munir, because his error path, stick diagram, and also layout and design rules check follow the requirement that we need to do throughout the mini project. So after that, we can continue in the metal graphic. So that's it.
So before we do the schematic on the mental graphic, we have to sketch it on a paper. But somehow we found a light mistake, where is the input and the output of C transistor is flipped. But we managed to identify the mistake, so it doesn't have any problem anymore.
We already done a schematic design. After that, we generate the schematic symbol which connect to CMOS transistor for identify the correct output waveform.
So after design the schematic and also the symbol, as we know, the symbol is actually to gain the output waveform. Our output waveform, as you can see, is same with the truth table that we produce. Next is actually to design the layout. The layout is actually based on our error path and also state diagram. So for more information about it, we're gonna continue with Munir and also Fakrul.
Alright, thank you. I will explain about the DRC and Fakrul will explain about the LVS. Where DRC is required for we to check the layout of our is correct or not. After we run the DRC for the first time, we receive the total errors is about 16 seed errors. Well, where the layout of our mini project have the error commonly at active and contact to active. Well, specification of the distance need to be at least 1.5 lambda, and our layout is 1 lambda. Another error is metal to metal, that we need to be at least 4 lambda, and for ground and VDD metal need to be at least 6 lambda between metal to metal, because of the size of the metal is larger than 10. And we have some mistake and some error for the placement, and we make some adjustment and correction. We run again the DRC and we achieve the specification, and DRC is success. After that, we know that our layout is good to go, and it will need to go to the next stage. That is LVS. Okay, Fakrul.
Thank you, Munir, for your explanations. LVS is the last process of our mini project. It functions to compare the netlist of schematic generated in DA and the netlist of layout generated in IC station. After completing the steps needed in the mental graphics, the LVS report will appear. Fortunately, we have obtained no errors in our LVS check and is considered a success in our first attempt. Thank you.
In conclusion, this mini project on IC design is provide us a practical learning experience for understanding the complexity of designing integrated circuit. This enabled for us to apply the theoretical knowledge to the IC design in using industry standard tool and methodologies. By completing this mini project, students can acquire a solid foundation to the IC design and pave the way for further exploration and innovation in the field of semiconductor electronics. A way forward, our group hopes that we can design an IC that can apply in any application such as multiplexer, decoder, and anything else. I think that's all for me and from my group. It's group 60, Niva, Fatihah, Sofia, and Fakrul. Thank you for lending us your ear, and bye-bye.